Okay, so you have 15 members going on a picnic, and there are three transportations, van and a car and a motorcycle. Each can hold 9, 4, and 12. 9 plus 4 plus 2 gives you 15, right? So all 15 members can go to the picnic with all three transportation working together. But now the question is like, how can you transport them? Like, you have to choose 9 people to be on the van, and then 4 people to be in the car, and the remaining 2 will be on the motorcycle. Uh, well, you simply have to pick 9 from 15. So 15 choose 9. That's your first stage. And then once those are done, now you have to choose how many are left? 6 people are left, right? So you have to do 6 choose 4 to put them in the car. And how many are left?
2.
2. And those go into the bike. Of course, this is just going to be 1. There's only one way to choose 2 people. You get 2 people. Okay? And because we're choosing by stages, the multiplication rule holds. Okay, that's a huge calculation, so I'm a little hesitant. Let's see. This is 9 factorial, 6 factorial. 6 choose 4 is 6 factorial, 4 factorial, 2 factorial. I'm using that formula that I just erased. It's n factorial over r factorial and n minus r factorial. 6 minus 4 is 2, right? 15 minus 9 is 6. That's what I'm doing. And then the last one is 2 factorial, 2 factorial, 0 factorial. Oh, I haven't talked about 0 factorial. 0 factorial, by convention, we just define it as 1. Because if you do that, all the calculations that we've done previously also works even if you have a 0. If you don't define it that way, then it becomes a nuance. So you don't do that again. So this is definitely 1 because these cancel. All right, what is this one? This one is 15, 14, 13, 12, 11, 10, and then 9, 8, 9 and afterwards, that's 9 factorial, so that's going to be canceled with 9 factorial. You still have 6 factorial, this is 6 times, 5 times, 4 times, 3 times, 2 times 1. And then we just did this in the previous question. If you try this one, you get 15. That was the answer to the previous question, choosing 4 items out of 6. And then we can do 5 times 3 is 15, so you can cancel with this 15. 6 times 2 is 12, so you can cancel it with this. And then, gee, I don't know. Yeah, so I'll just have to use the calculator after this. So can you help me out? Let's see, this much is, huh?
5,005.
5?
1,005.
Okay, so you get 5,005. Thank you. Yeah. Okay. So that's
times 15. Wait.
Oh, you still have 15 multiplied?
It's 75,075.
Oh, okay. 75,075. So that's the answer?
Yeah.
Okay, all right. So, yeah, that's quite a lot, right? Okay, now let me put a similar question, see if you can do this one. Okay. Question 2. How many ways can you split a group of 6 boys to play a game of 3-on-3 basketball? Think about this. 6 people, and you're trying to choose 3-on-3. That's a much simpler question. And it's pretty realistic too, right? Yeah. You may have 6 people one day, and then you're trying to form a basketball game of 3-on-3. How many different ways are there?
Is it just 6?
Why is it 6?
Because it would be 6 choose 3 times 3 choose 3.
Okay.
Wait, what?
All right. So
Just because you do 6.
you choose 3 people to form one group, right? And then you choose another 3 people to choose the next group. Okay. Now, but here's a catch. This would be correct if the 2 teams had names. If it was Tigers versus Eagles, then that's the correct answer. Okay. But right now, teams don't have names. So if you had A, B, C, and D, E, F split this way, they'll be same as D, E, F, and then A, B, C. You see what I'm saying? So the correct answer should be what? You have to do something after this. What?
Divided.
Divided by what? 2.
2.
Yeah. Now you wouldn't do this if the teams had names. Okay. So there's this subtle thing about that. Okay. So what is that? That's 6 factorial over 3 factorial, 3 factorial divided by 2. 6, 5, 4 over 6 divided by 2. That will be 10 different ways. So if you have a 3-on-3 game and you're hoping for a specific divide of teams, you're going to get that with probably a 1 out of 10. So it's like imagine this situation. You and 2 other friends went on the court, right? And there were another group of 3 boys on the court, right? And they decided to play 3-on-3 basketball. But because they didn't want to play like the same group, they said, okay, we will just decide by randomly choosing, and everyone does. I don't know how do you randomly choose, like this or that?
Yeah, you can do anything. You can do that. You could shoot for it. You can do it.
Yeah, something like that. And then randomly choose, and what's the chance that you end up with the same group of boys going against each other? That's 1 out of 10.